Okay, in this video, we're going to talk about strings in C++. So unlike C, C++ has a string class that we can use. Let me just go ahead and define a quick string. And let's print this string. And let's compile this and see what happens. And you'll notice we get some errors here. So string1 was not declared in this scope. Inline was not declared in this scope. But let's scroll up to the first one. Let's see. That usually will tell us. So string was not declared in this scope. Well, I thought that was a string class. Well, there is. We need to, first off, include string. And notice with C++, we don't put the .h in the include statement if it's a C++ include. So we still have some, even after including that, we still have a few errors. And we still have string is not declared. So we include the header file, but the other thing is that string is in the standard namespace. So if I do this, and I also need to do that with standard out and inline, and we use the scope resolution operator, which is 2 colons, and say that cout comes from the standard namespace. String comes from the standard namespace. So now I can run this and get the output I expect. So it can be a little bit tedious to keep doing this all over the place. So I'm going to take these away and instead put at the top of my program using namespace standard. And you'll see some debate on whether or not this is good practice. In general, you probably want to avoid this because you want to be explicit where your string, your cout, your inline, and so forth are coming from. However, the predominant reason not to do this is because what if you have some other string or cout or inline defined somewhere else? Well, hopefully that wouldn't happen because it wouldn't make a lot of sense. It would be confusing. Typically, the stuff in the standard namespace, you're not going to want to necessarily rename that anyway. So I don't have too much of a problem with doing this. Just be aware that in a larger program, it could be problematic because you can have namespace collisions where you have different classes or types or something that are defined different places with the same name. And without that scope resolution operator to specify which one you're talking about, you can run into issues. So just a quick side note on that. But I'm fine with you doing this for the programs you write for this class. Okay, so let's create some additional strings. And we can also define C-style strings if we want to. So char C string 1 is equal to C style. And I'm also going to, just to demonstrate, I'm going to create an integer, and I'll initialize that to 10. And I'll use that to demonstrate the toString method. I can append 2 strings. And I can even append a string object with a C-style string. Fix that compile error. Okay, so, and then that wasn't the only place I was missing that, as it turns out. So just some minor things that I'm dealing with. Okay, I don't have an unused variable warning. That's fine. I can deal with that later. So if I run this, notice we have hello world, hello C style, and then also this hello, which I should get rid of. Okay, so that's a nice facility that we have. It's a lot easier than if you were trying to work and do something similar to this in C. I can also append an int to a string, although I have to convert the int to a string first. So to do that, I use the toString function. And let's compile and run. And so notice it's appended that to the string. And to be clear, it's actually creating a string object there. I could do that here as well. So I'll just do an example where it's toString 45, and that'll append a 45 at the end of the string. So this is what was in string 3, and then this is what we append. So this isn't just for output. This actually creates a new string for us. Okay, so let's look at a few string functions that we have. So first off, we can replace part of a string. So I'm going to set string 4 to be I am a C++ programmer. So before I do the replacement, I'll print out the string. Now I'm going to replace 4 characters at index 0. And to do that, I use the replace function, which is a member of the string class. So I can call it using that object. So we start at 0. We replace 4 characters from and we replace that with the string UR. So now let's take a look at what it looks like now. And we have some typos, it looks like. I have an extraneous quote. And you'll notice it looks like that particular quote is what's causing most of these troubles. I bet if I compile now, those should mostly go away. They do. So let's run this. And you can see instead of I am a programmer, so these first four characters have been replaced by the string you are a C++ programmer. And notice we've expanded the size of the string while we do this. So even though you are is more than 4 characters, we add you are in place of those 4 characters. Let's replace 3 characters at index 10. So again, we're going to call replace. We're going to replace 3 characters, and we're going to say prologue. And let's identify these replacements. So we'll call this replacement 2. We'll call this replacement 1. And let's build and run. And notice we've changed the string from I am a C++ programmer to you are a Prolog programmer. So it's a pretty handy function to use. We can also get a substring of a string. So I'm going to create a new string, and it's going to be equal to the substring of string 4. So if I print this out, so this is going to be, so string 5 and we'll print that out. And if we run our code, notice that, so we see that string 5 is 3 characters of string 4 starting with the 4th, or actually starting with index 4. So you can see there's 4 characters, so it's the 5th character, but that's index 4. Starting at 4, 3 characters. So that's the substring function. There are times when you may want to convert a C++ string to a C style string. So let me fix that comment. So let me create a character pointer, and that function is called cstr. Wait, I don't want to do that. So now if I see out C string 2, and I have a few typos to clean up. Let me also make sure I put that that's string 5. Okay, so here I've created a C string, and I'm assigning it to the result of calling this C string function on an existing C++ string object. And you'll notice here when I compile, I get this invalid conversion from const char pointer to char. So this does need to be a constant pointer. Now it's important to keep in mind that this actually doesn't copy this string into this value. This just returns a pointer to that C string so that you can use it as a C style string. So that's why it has to be a constant pointer here. So if you wanted to change the string, you would actually need to do something to copy that out. And it's pretty straightforward in your code to do that conversion if you'd like.